Okay, all right. Good evening, everyone. Once again, my name is Ibrahim Suleiman, and I'm a blockchain developer. So, with the next couple of days, I'll be taking us through uh, testing, testing your smart contracts. So, I believe the past couple of weeks since the bootcamp started, we've been able to write a couple of Cairo programs and a couple of Starknet contracts as well. So I'll be taking us through how to write tests for those Cairo programs with rating, and also how to write tests for the smart contracts, the Starknet smart contracts that we've written. So just an addition to, just more info about me. I'm a big fan of open source contributions. So I'm big on the Starknet ecosystem. Yeah, that's just a little power about me. So, without wasting much time, I'm going to be sharing my screen now, so we can get started. Just a moment, please. Okay, I believe by now we can all see my screen. Can you please indicate if you can see my screen? Okay, I'm seeing a lot of responses. Thank you for that. Okay, so this is what I look like. And yeah, this is just what we'll be doing for for the next couple of days. So, so before we dive into writing tests for our Cairo programs, the first thing that we should know about is why test. Why are we writing tests? Because you might have, some of us that have interacted with. Excuse me, please. Some of us that have written a couple of smart contracts and deployed those smart contracts on the test net, maybe Sepulia or probably mainnet, and you might have interacted with the contract one way or the other using SNCast or Starkli. And the contract might work as expected, right? You might maybe write a Starknet contract that gives airdrops to certain whitelisted addresses. And you might feel like, okay, when you interact with it from the terminal, when you try to send tokens to the set of whitelisted addresses, everything works well. You might feel like, okay, since I've tested this, it works well in testnet, then why do I need to why do I need to write tests for it then? Right. A lot of us coming from Solidity background, when you write your contracts on Remix, you just click on deploy and you can see the contract functions there. You can interact with them easily. You can call the review function, you can call the write functions, and you just feel like, okay, why do why am I writing this test? So these are just a few reasons why you write tests for your smart contract. The first one is to identify and resolve security vulnerabilities, right? So when I mean when you start writing complex programs, right, you start working with larger teams and your project start having a couple of components, right? Like, one team is handling one part of the contract, another team is handling another part of the contract. In that case, it is difficult for one person to oversee the whole project as a whole and to be able to detect vulnerabilities. So it is when you write tests, right, that you can be able to detect such kind of loopholes or vulnerabilities in your contract. And uh, the truth is that for some for most of the bugs, for most of the loopholes in contracts that cause that particular project to lose probably millions of dollars or billions of dollars. Most of the times it is very, I mean, it is not easy. It is difficult to simply just reproduce such kind of bug manually. Right? You need to have a set of test cases that you can use to automate the process. So that is one of the reasons why we write tests for smart contracts. And secondly, to verify smart contract behaves as intended, right? So um, let's say, okay, there's what we call force testing, which we'll be looking at maybe sometime during the class. But let's say you have a function in your contract that adds two numbers, for instance, and the types that you're expecting is, let's say, a U8, which is very limited. Let's say you are trying to pass in, okay, initially when testing it manually, right? You use maybe you add 1+1 with the additional function and gives you 2. You feel like, okay, you exhausted all of the cases and your function works as expected. But maybe when you push it to production, when you push it to mainnet, and users start interacting with your contract and they start putting weird values, they start trying to add values that are above the range of U8, an unsigned integer of 8 bytes, that's definitely going to break. So if you don't write tests for such kind of scenarios, right, you're going to like fall into problems. Because if you are written tests for that kind of situation, you would have detected that, okay, when I put 1+1, it works, but when I put in a larger value like 1 million plus 1 million, it doesn't work because U8 cannot, you can't go, 1 million can't fit into U8 integer type. So that is just another reason to verify this smart contract behaves as intended. And lastly, to ensure the correctness and reliability of the smart contract. Right, this is similar to the first 2 points that I've talked about. You want to verify a contract is correct, right? Because as you keep getting advanced in writing your smart contracts, you begin to write contracts that are in form of libraries for other people, right? You begin to write reusable contracts for the developers. So if I need a particular functionality in my contract and the developer has written it before, and just simply use that contract, right, that was written by that developer. So now this is where the problem is. Me using the contract written by the other developer, how do I verify that this contract is not buggy? How do I verify that this contract doesn't contain loopholes or vulnerabilities? Because the truth is, no matter how secured my contract is, right, as far as I'm inheriting, using the functions, or I'm inheriting another contract that is not secured, then automatically my contract will inherit the vulnerabilities in that contract as well. So when you write there as a developer building building contracts that are to be used by other developers, when you write tests, the other developers that are intending to use your contracts, don't need to stress over reading the code or going over the complexities of how it works. They can simply check your test cases, and if you if you write tests for all of the security checks, all of the possible security checks that are known, and developers use it, then they can verify that, okay, these contracts that you've written and provided for them is safe and secured, right? Instead of trying to figure it out themselves. So these are just a few reasons why I would write tests for smart contracts. So the next we're going to look at is categories of testing. And the first one is unit tests. So for a unit test, the functions are tested individually. So the functions in your contract or Cairo programs are tested individually. So let's say, talking about the airdrop contract that I used as an example earlier on, when you have a function, let's say, uh, let's call it drop, right? Let's just call it airdrop. Right? You have a function named airdrop, and this particular function sends tokens to a list of a list of addresses that you haven't been an array or somewhere else, right? Now, aside from this function, there will definitely be other functions, but what unit test allows you to do is to test this particular function that gives the airdrop, right? So you test this particular function, uh, you test the functionality, right? Various test cases for that function. Let's say if the function sends airdrop, you first of all check, does this function send airdrop? If that test case pass, you check, does it send airdrop even when there is no token balances in the contract? You test a lot of cases like this on a single function. So that is why a unit test usually constitutes the highest number of test cases in the code base, right? Because for a particular function, you might have maybe like you might have 4 test cases for one function. I'd imagine you have a contract of that contains hundreds of functions. When you multiply that by 4, you're having 400 test cases, right, in your code base. So the next category we are going to look at now is integration tests. Now, integration tests, right, is this is when multiple contract interactions, right? This is when we test, multiple contract interactions, right? For instance, I have okay, let me still use the airdrop contract. The airdrop contract is one contract on its own, and it uses an ERC20 token that has been deployed to the mainnet. So if I want to write tests for my airdrop contract, I need to test how the airdrop contract integrates with the ERC20 contract that has been deployed on testnet. Sorry about that. Just give me okay. Cool. Okay. So talking about the airdrop uh, contracts. Now, the airdrop contract uses an ERC20 token that has already been deployed on mainnet, maybe 2 years ago, right? But how do you verify that the airdrop contract actually integrates properly with the ERC20 contract? This is where integration test comes in. And also, maybe in your code base, you might have various contracts. Right? Apart from the airdrop contract, you might have like a factory contract or something else. And you want to test, can you guys hear me? Can you verify? Can I get like your responsive? Okay, I can see a lot of notifications. Just give me a moment, please. Let me set something up. Okay, so sorry about that. I think my laptop was behaving weirdly. But I believe we're good now. So, okay, this is not what I was presenting. Okay, so for integration tests, right? Let's say you have, in addition to the airdrop contract, you have another contract like a factory contract, and these two contracts communicate with each other. Maybe you are importing some functions from the factory contract into the airdrop contract. You might want to test how these two contracts integrate with each other. You might want to verify that they they integrate properly without any bugs or loopholes. So the last, okay, and lastly, integration tests constitute fewer tests than unit tests, right? Because in this case, you are basically checking how multiple contracts integrate with each other and not really the individual functionalities. Okay. So the last category is end-to-end tests, and this simulates how users interact with your DApp. Let's say you built a smart contract and uh, you deployed it, you built a front end for it. So you need to verify that the front end actually the DApp actually integrates correctly with a smart contract. You need to verify that the functions are being called and the results are being returned properly. And this end-to-end test focuses on how the UI integrates with smart contracts. So these are a few categories of tests we have. And what we'll see next is, yeah, where this phrasing. Okay, so the next we're going to look at is tools for testing, and the most popular one in the Starknet ecosystem is the Starknet Foundry. So at this point, I'll just open these detailed documents. Okay, so one thing I didn't talk about earlier on is some things you need to know about testing in Web3, right? So writing tests in Web3 is different from Web2, right? Because in this case, you are testing immutable smart contracts, right? When you deploy your contracts to the blockchain, you can change it, you can change the code or the state. So it is there for forever as long as the blockchain lives. So yeah, it is immutable. So that is why it is different. But unlike your Web2, if you have a backend, you wrote like some API that communicates with your database. And I mean, developers do upgrade APIs like on a daily basis. So that is not the case with blockchain. So when you write your smart contract, you need to have this consciousness that number one, this is immutable, I cannot change it. So whatever mistake that is made will just be there, forever as long as the smart contract lives. Right. I mean, if you write a contract that locks your funds inside of it, when users send funds into your contract and there's no way to send it out, then consider those funds gone. So that is one of the mindset you need to have writing your smart contracts. Okay, Wisdom Genesis, can you go ahead? You have a question? Wisdom Genesis, you raised your hand. You have a question? Okay, you can just indicate if you have a question or anything you want me to clarify. So as I said earlier on, you need to write code with no room for errors. And in the case of Starknet, or maybe in Solidity, you might have come across variable smart contracts, but comes with some conditions, right? But the original design was that smart contracts should be immutable. Okay, no problem. The original design of smart contract was to be immutable, so when you deploy them, you cannot change them. And then one last thing I didn't mention here is that your code is open, right? Unlike your regular two backend where anybody sees the code and anything. So in the case of smart contract, your code is open. It's open out there to the world. So whatever you're doing, just make sure that you write your code be of the highest possible standard, both security standard and otherwise, because malicious actors will definitely, especially if you're reading a contract that holds a lot of funds, right? That holds users' funds, right? Malicious users will, want to come and take advantage of the contract. They will come experts, like people that knows how to track loopholes like better than anybody. Right. I mean, not really better than anybody, but these guys, they specialize in uh, you know, finding loopholes in your contract. They might just come and exploit your contract and drain all of the users' funds away. So yeah, you need to write your contract in highest standard possible. So we talked about categories of tests. And now before we move on now, we'll talk about DevNet, right? The DevNet is a local Starknet instance running in a machine. So a DevNet has pre-created accounts along with their private keys. So the Starknet blockchain, mainnet, the testnet that we all know that we probably deployed to, right? You can have an instance of that locally in your machine, an instance that you can have some degree of control over. You can spin it up anytime. You can create account, delete account, do anything you want, but just locally. It doesn't leave your machine locally. And this DevNet has pre-created accounts along with their private keys. And the accounts are also pre-funded with some amount of tokens, right? So these DevNets, right, they are pretty much useful for rapid development, when you don't want to you don't really want to wait You don't want to interact with the testnet directly because probably the time it takes and maybe the gas or any of those reasons. You just want to develop fast. Excuse me. Another thing about DevNet is that is requires how to manage the state of the network. It also exposes JSON RPC endpoints to interact with the network. And yeah, so for this particular line, right, if you deploy your contracts to the testnet or mainnet, you might have interacted with an RPC endpoint, right? But in the case of Starknet, you can maybe I think Voyager, I think Nethermind provides an RPC endpoint, right? And I think Voyager as well. So you might have used any of these RPC endpoints to deploy your contract and interact with them from terminal or from your front-end application, right? So uh, similar to this RPC endpoint that this node providers gives you, the DevNet also has them, and it runs on localhost 50/50. Like most of the DevNet runs on localhost 50/50, and dApps and CLI, your front end dApps, right, and even your CLI tools like SNCast can interact with this DevNet locally. So the two popular DevNets in the Starknet ecosystem are Starknet DevNet, yeah, this is the name. It's a ROS-based package, and the Katana. Well, Katana is a DevNet provided by Dojo. Well, I use Katana more often than Starknet DevNet because uh, Katana is integrated into Dojo. So I'm building a game on Starknet. So and I'm using Dojo engine, right, as a core of the game. And for that reason, for the fact that Dojo made Katana available for game developers to deploy the autonomous worlds to DevNet. So that is the exact reason why I use it more often than DevNet. But they provide the same functionality, right? Yeah, allow you to deploy your contract uh, to the Starknet, the local Starknet instance. So tools for testing, the Starknet Foundry, and the Starkli. Now, Starknet Foundry provides SM Forge, right? And let me just correct this. This is supposed to be SM Forge. So Starknet Foundry provides SM Forge, which is a test runner, right, that we can use to run the test for Starknet contract, and it also provides SNCast, which is like the CLI tool that you can use to interact with the Starknet blockchain from the terminal. And also Starkli is an amazing CLI tool that allows you to interact with Starknet from the CLI from your terminal as well. So the next we'll be talking about is writing tests for Cairo programs. So before we start writing tests for Cairo programs, you need to know that Cairo tests are functions that verify the functionality of Cairo programs are working as expected, right? Once again, this test basically functions on their own, right? And they verify that the functionality of our programs are working as expected. And they perform these three functionalities. Right, the Cairo test performs three functionalities. First of all, it sets up any needed data or state. And secondly, it runs the code, you want to test. Thirdly, assert the results, what is expected. So basically, these are the three, these are the actions that the Cairo tests functions carry out. So, okay, before we start talking about the anatomy of a Cairo test, let's simply create a new Scarb project that utilizes this test for us. So, what I'm going to do is I'm going to be using GitHub code spaces because I'm not going to use my machine to do the setup. The reason is because I already have all of these packages installed. I have everything set up already. So uh, when I use my machine to install them, might not be the same experience you face when installing it on your machine because I believe we all have we're all on different machines. Some are using Mac, some are using Linux, so some are using Windows and other varieties. So in order to be fair to everyone, in order to start, in order to do this on a common ground, I'll be using GitHub code spaces, right? So whichever machine you are on, whether you're on the Windows, you're on Linux, or you're on the Mac, I believe if you can access if you can access the web browser, then you can access GitHub Codespace. Right? But most importantly, I recommend everyone to use as a blockchain developer. Right? Most of these packages are optimized for Unix-based environments. So, if you're a blockchain developer, you need to use Unix-based OS, maybe Ubuntu. I mean, maybe probably any Linux distribution will work, or a Mac, but uh, these packages are, you know, optimized for those environments, right? And even if we go to GitHub Codespace now, GitHub Codespace uses Ubuntu, uses Linux under the hood. So if you have a Linux, if you are running on a Unix-based uh, machine, maybe Linux or Mac, it's not really compulsory for you to, I mean, it's not even necessary for you to use code space, but I'm just doing this for those that are probably using Windows because the packages might not install on Windows. So let's jump right in. So I go to github.com/code spaces. So I simply click on this option that asks me to create a new code space using the blank templates. So once this is done setting up, it will be like a uh, freshly, a fresh, uh, a fresh machine, right? Let's say a fresh environment. Let's say you are just installing maybe Ubuntu, and the way everything is clean, like no packages pre-installed and nothing. That is how this particular environment is at this point. So first thing to do, right, is to install Scarb. You can go to, you can search for Scarb docs in Google and it will take you to this page. So I will have to copy the first command, right, in order to install the stable release. So I just come here and paste that command there. Before then, let me change this thing to something more convenient. Nice. Yeah, I believe this is better. So Scarb is done installing. To verify that, I simply run the command Scarb version, and as you can see, I'm using Scarb version 2.2.4, Cairo 2.8.4, so 1.6.0. So after that is done installing, now if you want to check the list of commands that you can use to interact with Scarb, you can simply use Scarb in the zooming. Okay. Scarb dash dash help. Now this will allow you view a list of all of the commands that you can use to interact with Scarb from the command line. As you can see, we have add, remove, build, expand, and a lot of other uh, commands. But this is what we'll be using Scarb new because we want to create a new package. So let me do that. Let me call this Cairo. And you select the default installation. So now what we just did is we initialized a new Scarb project named Cairo project. You can use any name you want, but in my case, I just prefer Cairo projects. Okay, I'm gonna zoom in a bit. This is visible. So when you do ls, you can see that the folder is created from a new Cairo project. I just have to move into Cairo project. And this is the Cairo project. When you open it, you see Scarb.tommy. Now, this Scarb.tommy contains the configuration for our Scarb project. You can see the name, version, edition. You can also see dev dependencies, which is Cairo test 8.4. So let's check the source directory. Now, this is a very simple error program. It's like a boilerplate program, the Fibonacci function, right? And this is a test written for the Fibonacci function. So what I'm going to do now is to simply build this. So in order to build, I just need to run the command Scarb. So this is going to compile the project and generate the necessary CR file for the project. So yeah, it has built the project successfully, and so I mean, from the output, we can see that there is no error. So it means everything works as expected. So the next thing we'll be doing is to run the Cairo program. Now, lib.cairo, it is the entry point of every Scarb project. Whatever you have outside of lib.cairo, if it is not imported inside of lib.cairo, then Scarb wouldn't recognize it. Whatever program you have outside, if it's not in lib.cairo, Scarb wouldn't recognize it. Right, so now let's explore this function. We have the main function, right? And this main function is, as the name sounds, a main function indeed.cairo. So whatever is inside of the main function is the only thing that gets executed. Now, when you look at this Fibonacci function, you can see that it basically computes the Fibonacci of given number, say n, right? So you can see that over here in the main function, the Fibonacci of 16 is being computed for, and the output is being returned. And in this case, it's a U32. And okay, the Fibonacci returns the Fibonacci of 16, this particular line 2. And Fibonacci of 16 is in a type of U32. So when you compute Fibonacci of 16, it returns U32, and it is what our function over here is expecting. So I believe by now we know this is a shortcut in Cairo, right? When you put a semicolon, it means you just want to execute it and stop there. But when you don't have a semicolon, it means you want to return the result of whatever is here. So what this means is when you run this Cairo program, it's gonna compute the Fibonacci of 16 and return the result for us. So let's do that. So when you look at the output, they said returning 987, which is the Fibonacci of 16. So as you can see, it works as expected. And there's a little test here, a very short test that we can use to verify that without even running the program. And in order to run this test, we simply use so as you can see, this is the command to run test in our Cairo project. As you can see, it draws this particular test name, it works. This is the function that is being referred to. And as you can see, I said one passed, which means one test passed. And of course, which is this is the only test we have the code base. Okay, so before I move on, is there any question? I feel like just the only one talking. I just want to get a feedback from you. Do you guys have any question or anything you want me to explain before I move further to the next topic? Okay, there's no question. I believe we are all good. Okay, thank you, John Williams. Okay, thank you, Formatech. So, so good. Everything is good. Everything is going good and fine. Our programs, our Cairo project compiles and the tests are passing and the functions are running as expected. Now, what we're going to do is to build a simple calculator program. And this calculator program will have simple arithmetic functions like add, subtract, divide, multiply. So this, so after completing the arithmetic program, I will write tests to verify the correctness of these functions. Right. So let's do that. Let's create a file name calculator. So let's import the module. So first of all, clear this simply clear this. And so we are importing this calculator.cairo inside of our lib.cairo. You know, I told you earlier on that lib.cairo is the entry point of our Cairo program. So we are basically importing it into, putting our calculator into the lib.cairo so the Scarb project can recognize it. So inside of um, our calculator program, our first function should be add. Now this function should take in x of type I64, y of I64, and it should also return I64. So what this function, the life and purpose of this function is to add x and y and returns the output. And for just to state it once again, this is what I have here is like, it's a shortcut of saying let's res equals to this, and we return. So this is basically the same as just having x plus y and returning it. So we have another function, multiply x I64 and y of I64. Returns on I64. So it basically multiplies x by y. And returns the result. So the next function we'll be having is divide. And we'll call it if, takes in x of I64 and y of I64. So it returns an I64 as well. And x simply divides y. And we have another function named swap. This function takes in x, y, I64, and returns B64. So basically subtract y from x, and we have another function. This is like what this function does is like saying x to the power of y to the same I64 y 64 returns an I64 as well. So let's write out the algorithm for this function. We first of all have an I, just like a counter. The next thing is it's a value that keeps track of current value, right? The current value that is to be returned. Let it start as 1, and Now let's create our result variable. Now this result variable, right, to be the result of a loop, right? So if you have, let's say, 2 by 3, now this should be 2 times 2 times 2 times 2. Let's make it more obvious. Let's use 5. Let's see. So when you have 2 to the power of 5 is equivalent to 2 times 2 times 2 times 2 times 2. So 2 multiplied by 2 5 times. So that is what this result, the loop in this result basically does. So the first thing we do is to check if I equals to y. And if I equals to y, we break the loop and returns whatever value is. But if not, if I is not equals to y, which in this case our counter is not equals to the power we want to multiply x by, we simply take value, multiply value by x. This is also a shortcut. Right, it is a shortcut to say val equals val multiplied by x. This is a shortcut for val equals val multiplied by x. So the last thing to do is to increment value of I for the next iteration of the loop. So after the loop is done, you return whatever the value of result is. So that is it for the power function. We basically wrote a function that multiplies, that finds the power of a value. So after writing this down, the first thing we do is to verify the correctness of our code. Now, when you look at the list of commands that you can use to interact with Scarb, you see a command that allows you to simply check for errors in your code. Now, this helps if you have maybe hundreds of programs, and each time you want to check for the correctness of a new function you added, you don't need to run the hundreds of functions that you have. You can just simply check for the correctness, and instead of compiling and building, you can just keep all of those tests and check for the correctness. Now this is the command snap checks for errors, but it doesn't build the Sierra files. So let's see Scarb. Okay, as you can see, there is a bug in our code, say 29.6. This is 29, 6 is expecting semicolon. So after adding that semicolon, let's go back to check again. So as you can see, this is pretty much fast. And as opposed to building it, I mean, the difference might not be obvious at this point because you have very little amount of programs. But if you have, as I said earlier on, if you have a large number of programs, this will be very useful because those programs might take minutes, 10 minutes to compile. Right? But if you want to check, it takes far less than that. So after checking and verifying that it works, let's finally build. So this is what will generate the corresponding CR files of the programs. Now, everything works fine. We've established that. But let me just show you one thing. This is my calculator of Cairo. If I go to lib.cairo and I comment this out, sorry. And I come to calculator and I basically, this particular bug that we had before, I bring the bug back, the bug that arises from the missing semicolon. So if I try to run this, it's only if I check, Scarb check, you can see that could not detect this bug in calculator.cairo. Why is that? Because in our lib.cairo, the calculator module has not been imported. In this case, I imported it, but I commented it out. So this is the same as not being there at all. So you can see that if your modules are not in, if your modules are not in the lib.cairo, which is the entry point of your Scarb project, Scarb will not recognize it. So after bringing it back, that is removing the comment, and I use Scarb check, it's going to detect that error in calculator.cairo. I fix it, everything will be back to normal. So yeah, the next thing to do now is to write tests for these functions that we're writing. I mean, we just wrote this. How do we verify that it works as expected? And how do we verify that this particular algorithm works as expected? When we were recommending me to do that to write tests, which is what we're going to do in the next couple of minutes. So yeah, in order to write the test for this, okay, the first thing to notice, we'll be writing unit tests because these are all functions that we want to test. And if you go back to where we specify the categories of tests, you can see that unit tests comprises of the test you write for the functions in your contract. So that is what we'll be doing, writing unit tests to start to use this MG. I'm going to be explaining this in a very short while. This might be a little bit confusing, but just bear with me. This is a test. It's not a test. Right. Let's see 4 and 5. 4 and 5. Expecting 9. Okay, so this is a very simple test, right? That's test for the correctness of the add function. So as you can see, we are adding 4 and 5 and we're expecting 9. So in order to run the test as we did earlier on, we use Scarb. Okay, as you can see, the test add function passed. Right, so it means our add function was as expected, but let's alter something. Let's see, instead of x plus 4, we just want to say x. Okay, not even, that's too far. Let's just say something like x multiplied by y. So when you try to run the test again, you can see that something will happen. When you look at the outputs, look at the output summary. Say 0 pass 1 field. This is like adding more details. It's a test add function, okay? Panicked with assertion failed. So this is like what was executed. Like the add function multiplies for it, takes in 4 and 5 and returns to 20. But this is what we were expecting. So we're expecting 9 to be equal to 20, as you can see, which is of course not possible. So this is one of the importance of writing tests. Let's say you've written this addition function and you are confident that if they push it to production, there will not be a problem. And let's say the new intern that got into the company like yesterday is trying to make some changes and trying to impress you as a senior developer and mistakenly changes something like this, right? Changes this was initially plus and mistakenly changes it to multiplication. So there is it will be difficult for you to be able to trace such kind of changes, such kind of loopholes. But if you have tests, you don't need to go through those stress. You can simply run your test and figure out that, oh, my add function that was behaving as expected isn't behaving as expected anymore. And you come and you trace it and discover that, oh, this sign was changed. So let me run the test once more. So as you can see, the test is passing. So let's go back to the notes. Now, I believe we've seen a couple of new syntax and a lot of stuff, right, that are new to us. So I'll be explaining them the next step. Now, the first thing to know is test in Cairo is a function annotated with the test attributes. Right? So when you go back to our tests, you can see that, as I told you earlier on, the test functions are they are like functions on their own. They are like Cairo functions. Right? But the main difference between them is this test annotation they have. Right? Now, if you remove this test annotation, Cairo will not recognize this particular test add function not be recognized as a test function. So let's run that and see. You can see that the output, the summary, output summary is 0 pass, 0 field, 0 ignored, 0 filtered out. And that is because it does not recognize this as a test function. But when we bring it back, it knows that this is a test function, and runs it. As you can see, one passed. So that is the first thing to know. And secondly, when you run test with Scarb, Cairo test, Scarb runs all functions unlimited with test attributes and output the results. And another important thing to note is this CFG. This CFG stands for configuration, and it instructs the compiler to compile the code in the mode only when the test is being run. Now, if you look at this particular section of the code, it's a module named test, right? And we added an annotation over here. So what this means is that when you do Cairo, Scarb, Cairo, it doesn't run whatever, even if you like, even if you have 1,000 lines of code here, or you have 1,000 tests here, right? It will not be executed. Okay, let me fix. So when you run Scarb Cairo, right, it basically skips whatever is inside this configuration module. This, when you add this CFG test in any of your module, it means you're telling Scarb that this is a test. Whenever you are running the program, do not run it. And similarly, when you enter Scarb Cairo tests, you are telling Scarb to basically run only the functions inside of this CFG attribute. So only the functions inside of this our test module will be executed. Now, our addition, subtraction, division, power, none of this will get executed because we are running only the test, and this is what differentiates the test functions from regular functions. Okay, so the next thing we'll be looking at is assertion, right? We want to assert, the output of the functions in our Cairo programs. I want to assert that they behave as expected. So if you, as you can see, we're already using an assertion here that says assert equals this. So now this is the first assertion that we've used, and we say, so basically this assertion macro, what it does is that it takes in two parameters, right? And it checks for equality, right? If this is equals to this, then it marks this as successful and it moves on to the next. But if it's not equals to, if they are not equal, then panics and throws an error. So you have to verify that I change this to 8. The actual output is 9, but we're expecting 8. But so if you look at it, it says 9. The actual output is 9, but we're expecting 8, which is not correct. Now, when you look at the other assertions that we have, you have assert, and these asserts now, it checks, it is used when you want to ensure a condition evaluates to true. And it is unlike the assert equals that compares two arguments for equality, but assert only compares, it only ensure that, excuse me, only ensures that a condition evaluates to true. So instead of using this, let's use the assert micro to check, to test the add function. So simply say assert. So simply say assert that add 4 is equals to 9. If not, throw this error that says let's see, fail to add. So let's run this test and see. As you can see, the test passed. But when you convert this to maybe 8, the test will fail. Okay, no. This is I already commented this out, so it is like out of the code. This is what I'm supposed to comment. Change, I mean. As you can see, it said 0 passed, 1 failed, 0 ignored. So this is our main concentration, 1 field. And the reason is because this assertion failed. And similarly, we can use the assert not equals and just say assert not equals 4 of 5 is not equals to 8. Assert 4 and 5 is not equals to 8. So we're expecting this to pass. Similarly, for not equals, if you put the right, if the arguments right are equal to each other, then it's going to throw an error. So panic with assertion field. Okay, we're just going to make sure that these are not equals on the test. So yeah, our tests are passing, and the next thing to talk about is these nodes. Now, note that some languages and test frameworks, the parameter for equality assertion functions are called expected and actual. Some of us that have written tests for JavaScript programs before, when you're writing tests using ADAT to test your solidity code, you might notice that they use expected and actual in order to denote parameters for equality of the assertion functions. But in Cairo, the order by which we specify the argument doesn't matter. That's the first thing to know. And the second thing to note is they are called left and right. Instead of expected and actual, they are called left and right. So these are some other assertion macros. We have less than equals to. This is assert greater than equals to. Now another thing we will be looking at is panic. So when you expect a particular function execution to fail, you can actually specify that in your test. Should panic notation is what gives us access to that. So add should panic at the top of a test function. It means you are expecting that test function to panic. What is a panic? Let's take okay, let's take this out of here. Let's write test for the division function. So this is a test for the division function. Let's simply so what we are doing is we want to divide by 0. But before we do that, let's simply import the div function. Now, of course, you know that in math, in real life, you can't divide by 0. And same was implemented in computers. You can't divide, you're not expected to divide by 0. So let's try to do this and see what the result will be. But mind you, if you look at the division function, we are not handling any such kind of scenario. We're just simply dividing the values directly. So let's run this particular. Let's run the test now. Code base. Now, when you look at the output, let's say one field, test the field, test add is okay. So this is the failure message said panic with division by 0. So since we established that dividing by 0 causes the function to panic, we can actually expect it over here. Can expect this particular test function to panic. And since we are expecting it to panic, as you can see, the test pass. Now, this should panic is a bad practice because you don't know if you have a very huge program, right? And if you have a very huge program, right, with a lot of scenarios that can cause panics, right? You have various part of the function that causes panic. This is a bad practice because when that particular function execution panics, you won't know at what point it panics and you won't know the message that causes it to panic. You might be expecting it to panic with one message, but it might go and panic with another message, which is wrong. So we can actually specify a panic message like this. Let me just copy this for two. Okay, click on something. Okay. I was basically trying to edit. So let's take this out and now This is the message you panic with duration by 0. So we're just gonna use that here. Division by 0. Division by 0. So you can see that our test is passing. We expect it to panic the division by 0. But what if we change this panic message? What if it doesn't matter? The test will panic and we're expecting it to panic, but what we're expecting it to panic with is not what it will actually panic with. Let's see if the test will pass. So as you can see, the test failed, right? Because we're expecting it to panic with division by 0, but it's panicking with something else that we don't even know about, which is division by 1. I'm just going to change this real quick around just to verify that it works. Perfect. So you can see that it works and all of our tests are passing. So once again, I'm just going to take a short break and ask if there is any question. Okay, let me share the link to this note. Link public. So you can actually access it right from. Okay. So I'm just going to stop at this point and, uh, you know, verify if we are all following. If there is any question, anything you want me to go over, you can just indicate. So I'm just going to give us like 1 minute. And if there is nothing, if there's no question, I'm just going to proceed. Okay, okay, thank you, John Williams and John Baturo. In the absence of any question, I'm just going to proceed. So, what we'll be looking at next. Okay, what we'll be looking at next is filtering tests. So you can actually filter for tests, right, using the -f flag. So if I want to run really this test, I can simply filter for it by using Scarb. Okay, I think it's a double dash. It's not. Okay. It's not supposed to be Cairo. It's supposed to be Cairo test. Remember, we are testing this. We are trying to run the test, right? It's supposed to be Cairo test. So when the outputs get logged into the console, you can see that we have one passed, one filtered out. So what we did here was we filtered out any test that matches with test div. We use a regular expression to match. So any test that matches with test div is being run. So when you look at the two tests that we have, both of them start with test. Right, so when we filter any test that starts with a test and underscore, it will still execute the two tests that we have. As you can see, two pass, zero filter. Why? Because it matches with the name of both of the tests we have in our code base. So the next thing we'll be looking at is ignoring tests, where you can add an ignore notation on top of a test to ignore that test from being executed. And how can we do that? Let's see. Let's try to ignore this test add function and then run Scarb Cairo tests. You can see that in the output summary, you see one ignored, one passed. So why? It's because we added an ignore notation at the top of test add. When we remove it and we run the test again, so basically to run the two tests without ignoring or filtering. Let's simply bring this back. Okay, just before I bring it back, let me show you one last thing. If you want to run all of the tests, by including those that were ignored, excuse me, you can use the include ignored flag. So you can see after using the include ignored flag, all of the tests run instead of ignoring. Okay, let me bring this back. I'm ignoring this test, right? But first of all, let's start. At first, only one test will be run because one ignored, one passed because the second one is being ignored. But when I use the ignore flag, include ignored, it's gonna run the two tests. As you can see, two passed, zero ignored, because we are including the ignored tests. Right, we're including the ignored test into the we are including it into the test to be run all together. So that is it for the ignoring test. And one other thing we check is available gas. Now, available gas is what allows you to set the maximum amount of gas a function execution and consume. So before we put that into implementation, let me write the test for our power function. Now, this power function is a very is an highly the resource. It consumes a lot of resource, right? Because of this loop. So if you put 2 to the power of 1,000, this loop will run like 1,000 times. So that's a lot of gas. Now let's write test for this function. So we're testing power. So this equals to let's say 2 to the power of 10. 2 to the power of 10 is 1024. So we are asserting that the result equals to 1024. Else, okay, we need to import the power function before using it. We basically fail to take the power of a function. The power of the value. So this is a test. Let's run this test. Let's filter this particular test. Yeah, okay. We have an error here that says our function is not public, so let's make that public. Initially, sub, I think. We're only testing the power function. Okay, identify not okay. It is supposed to be power, not it's also a POW power. Very person here. Trying to be around. Now, okay, I-64 overflow. I think there's a question. How come we have to make this function public but be sort of the add function? Okay, that was not actually the problem. I will come to function visibility later on, but that was not a problem. Okay, so 1024 could not fit into I-64. Let's use something. Let's use 5. 5 is equals to 5, 1, 2. Okay, I think there is a bug in our function. There should be a bug in the power function. Let me quickly review this and see. Okay, so we have X, I think X of type I64, Y of I64, returns 964, and I and val of I64 as well. So this loop here, let's see. What's the name error with this? Overflow. Um, okay, thank you. We actually not using felt here. We're actually not using felt for the sake of simplicity. We are basically using, for the sake of simplicity, we are basically using using I64. Let me test this once more. So you can see that the test is failing. And why is it failing is because the power of 5 is not 1024, but rather 2 to the power of 10 is 1024. So let's run that again and see. So yeah, the test is passing now. There's a question. I. Okay, so thank you, John Williams. Test is actually passing now. Yeah, okay. This I, right? This particular I, at this point of the I is not interacting with any of the I64 variables, not interacting with X or Y. It's just incrementing by one. So we didn't need to convert the I to an I64. So this is passing now. So yeah, this is a very computationally intensive function, as I said earlier on. So what we're going to do now is to configure the gas. Let's put a very little amount of gas. This is let's say something way lower than this. Let's use a 200 gas, which of course we know will not be enough for this. So you can see that oh, no gas. Imagine this is even too low that they considered it to be no gas. But let's see. The gas was enough. So you can see that initially when I was very small amount of gas, easily execute. Yeah, look at what I'm looking for. Not enough gas to call function because I'm using only 2000 gas. I'm making only 2000 gas available for this function execution. So when it executes this power function, right, this power function is a loop. This loop alone is taking a lot of gas. So what this means is this loop is taking more gas to execute. And so when you put in a small amount of gas like 2000, it's not going to be sufficient. And why are we bothered about gas? You know, if you have a contract right to the mainnet and users are interacting with it, right? When they discover that the price, like let's say I'm building a game now, for every kick or for every punch I throw, I'm spending like $5 just to pay for gas fee. Even me myself building that game, I'll not play that game because it will be so expensive to play that. The fun will, we will just escape out of the game, right? So that is one of the reasons why we need to be conscious of the gas usage of our contract. Uh, I think, no, I don't think that's like an actual unit, or it's like 20 maybe joules or something. I don't think it doesn't have an actual unit. The gas is just like a number that's specified. Now, I don't want to go deep dive into the Cairo VM and how it works, but just know that each of these execution, right, they have like a specific, they have a fixed unit of gas assigned to them. Like, for instance, now this variable assignment, right, in curve the Cairo VM, it has a fixed amount of gas, right, that it consumes. This also consumes a fixed amount of gas, and looping, inside the loop, assigning, comparison, breaking, assignment, all of these things, right? They sum up to consume gas. They have units of gas they consume. So that is it for gas. Right? You can specify the uh, amount of gas your function will consume. The test function will consume. So lastly, let's do something weird. Let's try to call this subtraction function. Space test function tests show. So we want to do something that will cause the solve function find. So that's one, let's say sub of course you need to subtract. If you do 2 minus 5, it's a problem. So let's run this particular function. Okay, we need to filter it. Okay, I forgot to import the sub function inside of the test module. Now, this module. This is a different module itself, right? And according to Cairo, right, this particular module, these functions that were created up here are not available by default inside the scope of this module. So we need to import those functions manually. Okay, that is the warning. The recording will stop in 2 minutes. Is there any particular reason why it is stopping in 2 minutes? Okay, let me just use the 2 minutes to round up what I want to say. So this is the basic. Any particular reason why this? Okay, no, this is supposed to be. Okay, this test is passing. So let's see. Let's print out the output. Okay, this is supposed to have a semicolon. Let's just call this res. Let's for this. So we know how to identify it. So as you can see, this returns -3, right? And this is actually expected. So let's start the res to 3. So this particular test case passed, and this is just to show us that our sub function, right, can handle negative values as well. So this is like a scenario where you test all of the possible use cases of your function. In the case of the add, we only test for the adding two numbers together, like 4 and 5. But for subtraction, we're also checking that you can subtract a bigger number from a smaller number, and this is the expected output. So this is what we'll be stopping for today. We'll be calling it today, and in our next class, we'll be looking at Starknet Foundry, how you can set it up and write your. Now you can run the test, right, for your Starknet contract. So I already shared the link to this document in the chat. So you can go through it, and in the next class you come with your questions and we make it fun and interactive together. So that is it from me for today. If there is any question, you can indicate. You can ask me. The next 2 minutes I'll be taking questions in the next 1 minute. So have anything you can just start presenting. So in the next 1 minute, which is 10:30, there is no question call it a day.